Good morning, class 12. I, Sana Uzma from the Millennium School, South City, Lucknow, will be discussing with you the concept of molar conductivity at infinite dilution. The effect of dilution I've already discussed with you in my last session, where you saw that on diluting an electrolytic solution, the specific conductance decreases, rest all the other factors, that is conductance, the molar conductivity, the equivalent conductivity increases on increasing the dilution. So today in this session you'll learn about the effect on the molar conductivity at infinite dilution. Infinite dilution can be represented as, if I talk about the molar conductivity at infinite dilution, it is represented as molar conductivity at infinite dilution. And if the dilution is infinite, obviously the concentration will be almost zero. So with the help of these two signs, we represent the molar conductivity at infinite dilution or zero concentration. To explain it better, children, I have a chart in front of me where you can see that three columns are there. The first column is the dilution factor, where it is represented that how much water is being added to dilute it, and you can see there is a gradation of 10 ml at each level to study the effect properly. In the second column, you can see the molar conductivities, the values of molar conductivity is mentioned. And in the third column, you can see that the effect of dilution on concentration is mentioned. Obviously, dilution is inversely proportional to concentration. So as you will increase the dilution, the concentration will go on decreasing. Now let us observe this chart in detail, this table in detail. Children, you can see that in the first row, when the dilution factor is 10 ml, the molar conductivity value is 130 and the concentration mentioned here is 0.3, as you can see here. And as the dilution factor is double, that it is now 20 ml, the molar conductivity value has increases to 135 and the concentration has gone down. So like this, every time 10 ml of water has been added. But you can observe after some time, that is after this value, the molar conductivity value has become constant. You can see that after third level of dilution, that is after 140, the value of molar conductivity has become constant. That is, now there is no net effect of dilution on the value of molar conductivity, and also the concentration has become constant. That is, you can dilute a solution up to a certain level, beyond which even on diluting there will be no effect or no change in the value of molar conductivity, and that particular value is considered as infinite dilution or zero concentration, as you can see here. Now moving on to the next slide. Here you can see that the values, the same table is represented where I have marked the values. At 40 ml, the value of molar conductivity is 145, where the concentration has become 0. Now on further diluting, when the concentration has become 0, when do we say that concentration has become 0? Zero concentration means the electrolyte, the salt which was present in the solution is almost negligible, is near about negligible in comparison to the volume of the solvent, because you have diluted it to such an extent that the electrolyte or the solute has become negligible. And when such a stage reaches, the value of molar conductivity becomes constant. Here you can see, children, what does this infinite dilution means is written. It is a point or volume at which molar conductivity not increases or remains constant after dilution. So this is the highest volume after which, or this is the maximum volume reached, that when after this, when you dilute a solution, there will be no change in the value of molar conductivity, or there will be no change in concentration. That is why I told you that this is denoted as molar conductivity at zero concentration, or molar conductivity at infinite dilution. So I hope this is clear to you. Now moving forward. So the infinite dilution depends upon the three factors. The value of molar conductivity at infinite dilution depends upon three factors. The first factor is the type of electrolytes. That is, there are different types of electrolytes. Obviously, the value of molar conductivity will depend upon the type of electrolyte, and it depends upon the nature of the solvent, whether it is water or some other solvent, and it depends upon temperature. So these are the factors on which the value of molar conductivity at infinite dilution will depend upon. Okay, now molar conductivity at infinite dilution will depend upon one more factor, that is whether the electrolyte is strong or it is weak. In my last class, children, I discussed about the effect of dilution on strong electrolytes and weak electrolytes separately. So I have mentioned it in summary here. You can see here, for strong electrolytes, the current carrying ions, that is the number of ions, does not change. Why? Because their alpha, their degree of dissociation is already 100% in this case. But what happens? The ionic mobility increases. So net resultant is what? Net resultant is the conductance. The conductance will increase. This is what we learned in the last session. Now